Yo, what's up, guys? I'm Engineer Mujib. Welcome you all to my YouTube channel. So, today we are starting our course on the heat treatment processes. In today's lecture, we will only be discussing the introduction to heat treatment processes, and some applications. Okay. First of all, as you see in the slides, introduction. What is heat treatment? Heat treatment is a series of operations involving controlled heating and cooling of metal or alloy in solid state to obtain certain desired properties without a little change in chemical composition. Okay, the heat treatment is a series of operations and that can be controlled by the heating and cooling of the metal in solid state to obtain desired properties without or little change, means changing or not changing the chemical composition. We vary the properties as a desired in desired composition. Okay, next thing is heat treatment. Generally represents a combination of thermomechanical and thermochemical operations aimed at altering or imparting mostly mechanical and physical properties, but also chemical properties of material. Okay, the heat treatment is generally a combination of thermomechanical, like those variations occurring in the body, in the material, due to change in heat in the physical structure or the chemical structure. Mechanical and physical properties, but also chemical properties of the material, which means the vary without changing the shape of product. By heat treating, a metal can be made harder, stronger, and more resistance. It means here the thing we discuss is, in heat treatment we can utilize, we can change, we can enhance the properties of some material by heating it, by treating it with heat, but not by destroying its shape or the physical appearance. Heat treatment can also make a metal softer and more ductile. It means heat treatment processes could be applied on a material to make it more ductile or softer. It can be utilized to increase service life of a product by increasing the strength and hardness, or prepare the material for enhanced manufacturability. Heat treatment processes are very useful for enhancing the properties of material and its life, and making it more compatible and reliable. Now going towards the applications. Heat treatment and surface engineering. Surface engineering find their extensive applications in area of design and manufacture of strategic components in a wide range of engineering sectors, including air, sea, and land transportation, energy production, mining, defense, or agriculture. Okay, so heat treatment and surface engineering, they are very applicable in enhancing the materials for use, for their use in different fields and different things and different operations, like energy production, defense, like making guns, making parts of some ammo, and the land transportation, of course, and mining, and sea. It means the ships and the parts of the ships can be enhanced to different properties and to face different atmospheres and different atmospheres and temperatures and pressures, kind of things. Okay, the most pronounced beneficial effect of heat treatment in altering microstructure enhanced properties is to range of ferrous and non-ferrous alloys of copper, zinc, aluminum, titanium, magnesium. Okay, and the most pronounced, this means the heat treatment is mostly used for altering the non-ferrous and ferrous, both of the alloys of copper, zinc, generally titanium, and magnesium. Of all materials, steel is the most common and the most important structural materials, are particularly suitable for heat treatment. Okay, of all materials, from our materials, generally we do the heat treatment processes to the steel, so that we can various important structural materials. We can make it reliable in its different states, in its different structures. Heat treatment of steel is inherently associated with an improvement in strength, ductility, grain size, and relief of internal stresses, machinability, and formability. And by heat treatment, we can inherently improve the strength, the ductility, the grain size, and nuclei size of the structure of the steel, and relief of internal stresses, machinability, and formability. Like we can increase its improvement in handling. The main processes include normalizing, annealing, quenching, tempering, cold, and cryogenic treatments. This means the main processes involving in heat treatment are normalizing and annealing, quenching, tempering, and cold and cryogenic treatment. Although the heat treatment has been in practice for millennia, an understanding of the science and associated principles has only been developed in last century. Since the heat treatment is kind of full of modern techniques to increase strength, hardness, and wear resistance. Heat treatment is used to increase strength, hardness, and wear resistance, bulk hardening and surface hardening both. To increase ductility and softness, like tempering, recrystallization, annealing. To increase toughness by tempering, recrystallization, annealing, and to obtain fine grain size, same by recrystallization, annealing, full annealing, and normalizing. Now, the objectives of a heat treatment are to remove internal stresses, like we discussed before, induced by differential deformations by cold walk-in, non-uniform cooling by different temperatures and different atmospheres from high temperature during casting and welding, stress relief annealing, the process we call it. And to improve machinability, full annealing and normalizing are used. To improve cutting properties of tool steels, hardening and temperature we use, To improve surface properties, surface hardening, high temperature resistance, precipitation hardening, and surface treatment. These processes are used, the steel undergo from these to improve the surface properties. To improve electrical properties, we do recrystallization, tempering, edge hardening. To improve magnetic properties, hardening and phase transformation are used. The process is variable, so the things that can impact, that can vary in the processes of the heat treatment or temperature. It means change in temperature can impact holding time of the material, heating rate of the material, and cooling rate of the material, of course, and also the most important, the furnace atmosphere. The furnace atmosphere would surely be big part in impacting the material we process. Okay, that was it for today's lecture about introduction and applications of the heat treatment. In our next lecture, we will briefly discuss the process variables about the temperature, holding time, means how they can impact the heat treatment processes. For now, see you. Kindly, if you have not still subscribed our channel, kindly subscribe it, and so that we can